Okay, so here we are with part two of lesson 19. Sorry, I had a little mishap at the end of that one, and it was also quite long. So I figure I'll go ahead and put it into two parts. So in example two, now we're going to talk again about something we talked a while back about, and that was in module one, and that is this idea of discounts. Okay. Yeah, and we're going to be using more and more now. We're going to be using decimals, okay? Because we are going to talk exclusively about a 20% discount, all right? And I will compare this with the tape diagrams, using tape diagrams again, okay? So bear with me as I do this. I'm going to try to step you through this a little bit. I don't want this lesson to be too excruciatingly long, but it does take some good explaining, especially for some of you who don't feel as confident with all of this. Okay, so here's what we're going to do. What I want you to do, we will do together, and then have you do it separate. Try to tackle some of these on your own. Is that we're going to start from different original prices. Okay, now any original price is going to be 100%. Okay, and 100% is the whole thing. It's what it originally cost. Okay, and then we're going to work exclusively with a 20%, like I had mentioned, 20% discount. And discount is just the money that you remove or you take off. That's your savings. Okay, that's how much money you're saving on a sale. Okay, so you can see the discount, the original prices are going to change here. You have $100 here. You started from 50, and then 28, 14, 50, and at the bottom here it's X actually. So you'll see how that X is more or less just a formula that you'd be able to apply. Okay, so let's do the 100 together. So if I'm going to find the discount for $100, I would go ahead and I would take my 100, okay, and talking in terms of decimals, I would go ahead and multiply that by 0.20, okay, it doesn't, 0.20 and 0.2 are the same, but just for the sake of being able to see that this 0.20 is actually 20%. It's the decimal version of 20%, and I know many of you have done this in the past. Most of you, all of you should have, but some of you might not be quite familiar with it yet, okay, or quite comfortable with it yet, let's say, okay. Now, the reason why I multiply here, because you might be thinking, hey, well, I'm taking money off, don't I want to subtract or divide or whatever, but I'm multiplying, but notice what I'm multiplying by. I'm multiplying by a number that is a rational number here that is less than 1, okay, 20%. So what I'm trying to find out is the discount. So if you go ahead and take you could do this long multiplication, or you can go ahead and do this on your calculator, you will find out that if I multiply 100 by 0.20 or 0.2 or 2/10, I'm asking what's 2/10 of 100. If I looked at that, I can look at it here. Let's say if I went ahead and instead of multiplying this by a decimal, I can go ahead and multiply it by a fraction. Okay, so this right here, this 100 times 0.20 is the same as 100 over 1 times 20 over 100, and you know I can cross divide here, 100, 100, 1 and 1, and then I'd have 20 over 1, which is my answer, which is 20. Okay, so if you want to look at it in terms of fractions, if that's helpful to you, that is fine. I like the fraction application a lot. Okay, they're trying to emphasize right now more or less the decimal aspect of all of this. So again, now we'll just fill that in. So a discount amount, 20% off of $100 is $20. Okay, so that is our discount amount. Okay. Now the new price, the way you would write out the new price, and again, some of you are going to be able to say, well, 100 minus 20 is 80. That's right. But let's go ahead and write that out anyway. minus 20 equals 80. Okay, so that is our new price. Our new price is $80. Okay, because that represents a $20 discount off of $100. Okay. Now the expression, and here's what they're trying to cut to, the expression. So the way we started out, if we look at all these different steps, we started out with 100. That was our original price. And then we subtracted away our discount, which looked like this, 100, remember, times 0.020, okay? This is what we started out with. This is how we did it. Here was this first part right here is here. This second part here is right here, okay? So this is what our expression is so far. Now we can combine this, and if you notice that we could actually put, we can make this look a little simpler, let's say, because we have these two 100s here. We could go ahead and we could put 100, and then we could put parentheses, 1 minus 0.20, okay? All right. So what we've done here is we've gone ahead and now we can just, if we distributed this out, we would have 100 and then we would have, 0.20, okay? So, but this then simplifies down to this, 100 times 0.80 or 0.8, okay? So this becomes the expression in the end, and it's kind of like a roundabout way to do it in a sense, because if you're going to find the final price after a 20% discount on $100 original price, you're going to multiply it by 0.20 to get the discount amount, but you're going to multiply it by 0.80 to get the actual cost, the new price, which is $80. So this actually here would equal that. Okay. So let me go ahead and I'm going to step through it with you again with the 50. The 28, the 1450 become a little bit more complicated. Not necessarily too complicated, but a little bit more complicated. Not as straightforward as using the number 100, for example. So. Okay, but again, I want you to apply this. I'm just going to come back. I don't want this lesson to take too terribly long, okay? But actually, you know what we should do? Why don't I go ahead and take this first one, this first question, since it is so easy and has such simple numbers. Let's go ahead and look at that in terms of a tape diagram. So if we look at this and we look at $100, this was our first problem. We had $100 and we wanted to find, what 20% of that 100 is. And again, it seems kind of silly because it just seems kind of easy. But just to look at this tape diagram and the way it was drawn out. And the reason, and hopefully you know the reason for it being divided into 5 sections, okay, is that we were talking about 20%. Now 20% is the same as 1/5, okay? 1/5. So you need 5 20% pieces to come up with 100%. So this entire, the entire length of the tape is 100%, and that equals $100, okay? So that's our original price, all right? So if we look at the discount amount is going to be 20%, okay? And 20% of that right here, we can go 0 to 20%, this right here, that's going to equal, this is 20%, okay? So that is equal to $20, all right? And that's what we saw back there, our discount amount. Now the rest, the leftover, the other 80% is worth $80, okay? So we can tell that $80 is equivalent to 80% of the original price, okay? And then the $20 is equivalent to the 20% of the original price, okay? So we could see the tape diagram form. If you compare that to this here, I mean, what you're doing is you're doing exactly the same thing. but showing it in tape diagram form. So hopefully that helps. We can maybe could do another one like this as well. But like I said, I don't want this to take too long. Okay, let's go ahead and do this 50. So the same thing, we're working with 20%, okay, working with 20% again. So we're going to do 50 times 0.20, okay, and so 50 times 0.20, if you, again, I'd love for you to become more and more proficient with this, but if I've already told you that this, 0.20 or 20% is the same as 1/5, you might understand that 1/5 of 50 is actually 10, okay? And again, just to show you fraction-wise, we did it with fractions. Again, you can do this on your calculator if you want, but I'd love for you to see what it is. 50%, 50 over 1 times 20 over 100. And again, we can just go like this. We have, that is going to be 1, and that is going to be 2. And then we multiply across, that's 20 over 2, which is the same as 10, okay? So again, using fractions here might be a little bit more friendly for you. And again, it's never, you can never use fractions too much. Let me tell you that, okay? Especially with all that's ahead for you guys. You're not going to see decimals all that much, but we're using decimals now. So here we go. Here we have our discount. Our discount is 10. To find out our new price, of course, is going to take that original price, subtract away that discount, and then you're left with your new price, which is $40 here. To create an expression, just like we did up top, have your original price, subtract away your discount, okay, which was 50 times the 0.02. Put this all together, so we can only have 50, and then we have 1 minus 0.20, and which is 50, of course, times 0.80. Okay, so you can get the idea that this whole column here is going to look very similar. Okay, here you have up here you had 100 times 0.80, 50 times 0.80. Down here you're going to have what you're going to have here. Can you guess? That's right, 28 times 0.80. Down here you're going to have what? That's right, 1450 times 0.80. All right, so you're getting you see a trend. These are always going to look the same here. So this expression side is helping you find your final price using an expression. Okay. So why don't I leave you to do this? Go ahead, and I'm going to solve these while you pause, and then I'm going to come back and I'm going to have each one of these solved. All right, and I'm just going to let you look at them because I'm going to leave them there for a little while. You can pause and go over them. Pretty straightforward stuff, though. Okay, so, but again, I do understand that it might take some time to get really proficient at this. Okay, so go ahead and work these out on your own, and then come back and we can look at them together. Okay, so here you have the solutions to all three of these. Just go ahead and check them out. 28 and the 1450. Check your math. Make sure you understand it before you move on. But let's just go ahead and look together at x though first. I just wanted to take a look at this bottom one here. So x, this is going to present a little bit of a different result in that when you multiply to find a discount here for x, you're multiplying x times 0.20, and the way you express that is this way. Okay, you always put that x trailing the coefficient. Okay, it's always going to trail it. It's not proper to put it like this, 0.20. Okay, you don't write it like that. You're always going to have it after, because x stands for any number. I mean, it's a variable. It stands for anything. So if it were 1450, you could just plug it in. Okay, you could plug it in. And then if we're going to find our regular price, you would just take whatever that value of x is and subtract away the discount in the form of 0.20x. And again, this, of course, if you're going to find your final price or your discounted price or price after discount, you would just do x times 0.080, okay? Or could be 0.80x as well, okay? Okay, before we move on to example 3, I just want to talk about this idea of using a tape diagram when the percentage or the percentage discount is not as convenient as 20%, let's say. Okay, so we have here, it was easy enough to split this 100% up into five, whoopsie daisy, five 20%, okay, because we know that 20% is the same as 1/5, so there are 5 even pieces, okay. If I just took, we'll just leave that there for a second, and let's go ahead and let's talk about, I mean, sometimes you get a discount of 15% or 30%, and I just wanted to show you how you could go ahead and still use a tape diagram, even though it's not as convenient. Now, 30%, for example, how would you split up 100% into 30%? I mean, you really couldn't. There's 30, and then there's another 30%, and another 30%, but then you're left with another 10% just sitting here. Okay, this is not going to work out. Okay, it's not going to work out. All right, but what you can do is you can take that percent that you're working with, which is 30, and then 100%, which is the total, you know, what the entire strip or diagram is worth, okay? And you can find a greatest common factor, okay? And again, all of these fraction concepts just come into play. A greatest common factor of 30 and 100, and if you do that, you will know that that is actually 10, okay? Because 10 can be evenly divided into both 30 and to 100, and it is the largest number that can do so, okay? You know, 30 also has a factor of 15, but 15 doesn't go into 100. 30, of course, has a factor of 30, and 30 doesn't go into 100 evenly either, okay? So if we go ahead, and again, we're going to take, the way to do this now is to take the percentage that you're working with, okay, which is 30%, and 100%, which is the value of the entire diagram, finding a GCF. In this case, we found out that that was 10. So now what we do is we're going to split this 100% up into 10 tens or 10%. So that'd be 10 pieces. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think it's 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. So the reason I split it up into 10% pieces. So each one of these pieces here is now 10%. And this is my percentage here. 10%, 10%, 10%, 10%, 10%, 10%, 10%, 10%. So 10%s are 100%, okay? So now in terms of 30%, so 30% of this diagram is right here. It's 3 tens, okay? So here is a 30% of my diagram, okay? So it's real easy. So let's say let's do the same here. If I had an original price of $100, okay, $100, splitting this up into tens, I know each one of these 10% is going to be $10, okay? We're just keeping it easy here, all right? 10%. Each one of these 10% pieces is going to be worth $10. So if I had 30%, I'm looking at $30, okay? So you can see how easy that makes it, okay? GCF. Let's just go ahead and let's do another. Let's just take this one out since we're familiar with that one already. Let's go ahead and make another tape diagram. Let's make it of $15. I mean, sorry, not $15, 15%. Okay, so let's create a tape diagram that can show or can symbolize, be able to symbolize 15% pieces. Okay, again, you can't do that cleanly like you could the 20% or like you could a 10% or a 50%, but a 20%. I mean, I'm sorry, we're talking about 15% now. We're going to do the same thing as we did down here. We're going to look at the number 15, which is 15%, which we're trying to work with, and 100%, which is the value of the entire diagram. And we're going to find a greatest common factor. Again, we're back to this GCF. Very, very powerful, powerful concept now, and one I hope most of you have in your arsenal of tools, okay? So if we look at that, a greatest common factor of 15 and 100 is going to be 5, okay? Because 5 goes evenly into 100. It also goes evenly into 15. There are no other factors of 15 that will go into 100 evenly, okay? So 5. Now I need 5% pieces, okay? So each of my pieces needs to be worth 5%. So if each of my pieces is worth 5%, and I have 100% total, that means I need 20 even pieces. As you can see down here, I needed 10 even pieces. Now I'm going to need 20 even pieces. This is going to be a little bit more challenging, but so let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 18, 19, 20. Okay? I think that's right. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20, yes. So each one of these pieces is going to be 5%. Okay? Each one of these pieces here is worth 5% of the total, because the total is 100%. Okay, I'm having trouble putting the 5% up on the top there, because there's a little toolbar up there that wants to keep coming down. Okay? All right, so each one of these is worth 5%. These are all percentage pieces, okay? All right, so therefore, if I were to find, and again, we're looking for 15%, that's why we went ahead and did this. If we're looking for 15% of an original price, and again, let's just use that original price as $100, okay? So that means this whole thing is worth $100, okay? Each one of these is going to be worth how much? Okay, so we have 15 of this. We've split it up into 20. Okay, so 20 pieces to get to 100, where each one of these is going to be worth $5. Okay, so if I do 5, 5, 5, that is my 15%. Okay, because that's 3 5% pieces, and that means that 15% of 100 is $15. Okay. And again, these are simple numbers to work with. Working with the number 100, a lot easier. But just thought I would show you that. Maybe go back to that if you need help. But if a tape diagram is going to help you, and especially help you check your work, you can create tape diagrams of all kinds of percentages by finding using the GCF concept. Okay, now example 3 was going to have you go ahead and apply some of your knowledge, your newfound knowledge. Now A is just asking you first, okay, well, let me read the problem first. So an item that has an original price of X dollars, okay, we're not given a actual dollar amount yet, is discounted 33%, okay? So all you need to do first is to write an expression that represents the amount of the discount. So that's the expression only, okay? So write the expression, because we don't truly have an original price yet. We don't have a dollar amount. We have just a discount of 33%. So go ahead and write that expression down. Okay, so if you remember what we did prior to this, when we had X, we just went ahead and put our decimal equivalent of 33%, and we put it in front of the term X. So this is going to represent the amount of the discount. Okay, so I can now plug in a number. If I have an original price, I can plug that in for X, and I can go ahead and calculate what a 33% discount would be for pretty much any original, well, not pretty much, but any original price I want to throw in there. Okay, next task here is to write 2 equivalent expressions that represent the new discounted price. Okay, so you can go ahead and write 2 equivalent expressions here that represent the new discounted price, and you can look back again at the problems we did prior to this to help you out. So all of these here would be equivalent to the new discounted price. Now this is the new price. This is not the discount. This represents the discount right here. That's an expression for the discount. Now these down here would be, if you're going to take x, you're going to subtract away the discount right here, which is 0.33x. Okay, the expressions we come up with would be this one. We could have x multiplied by 1 minus 0.33. Okay, or finally, which is more the simplest way to express this new discounted price, would be x times 0.67. Okay. Okay, next task here, the C, it says use one of your expressions to calculate the new discounted price if the original price was $56. So now we have an actual numerical value here of $56, and we can actually apply that or plug that into our expression. Now one expression we didn't mention up top here, B, and B for this one is would actually be 0.67x. Okay, that's probably the most useful and popular expression we could actually use. Okay, so if I were to go ahead and use that, I know that here's my expression. 0.67x is going to give me my new discounted price. Again, this is not the discount, but this is the new discounted price. If I plugged in, then I went ahead and plugged in 0.67, and I plugged in 56 for my x right here. Okay, so this becomes this now. All right, 56. I could do calculation. I could calculate that do it on a calculator. I don't care how you do this right now. $37.52 would be my my new discounted price. Okay, so that's taking an original price of $56, discounting it by 33%. Okay, which is right here, and then getting a value or a new discounted price of $37.52, which represents 67%, or 0.67 of the original price. Okay, so here this question D is interesting. Hopefully it's not too much for you right now, but I'm going to ask it anyway and go ahead and have you use it. We'll probably be applying it in the near future. And it asks here, how would the expressions you created in parts A and B have to change if the item's price had increased 33% instead of decreased? Okay, so the way we figured out with the decrease of 33%, we went ahead and we took our 100, or 1, and if you subtract away 33, 0.33, you are left with 0.67. Okay, so that was going to be our discounted price. Okay, our discounted price was going to be this. All right. Now, if we're going to add. Okay, we're going to increase by 33%. That means we're going to add 33%. So if we took that x and then we added 0.33x, okay, you can see now, like we had talked about earlier in this lesson, this idea actually in part 1 of this lesson is that you would add like expressions. Now, x is going to be equivalent to 1x. Again, we always assume if you have an x sitting there by itself, it's 1x, okay? So we add 1x to 0.33x, and that's going to equal 1.33x, okay? So if we were to increase the price of x by 33%, we would use this expression, okay? But discounting it, decreasing the price, we're going to use 0.67. Okay, and we'll work more with that in in the future. Okay, well this this example 4, this next little discussion and activity we're going to be doing is going to deal with something known as sales tax. Okay, now many of you may understand a little bit about sales tax, but we could talk. Actually, going to explain that a little bit more right here. Now, sales tax is an amount of money that's actually paid to a state government. Okay, so for example, when you go out, and this is pretty close, I think around here in our area. I know Modesto, I think it's like 375 or 325 is the actual sales tax rate, and I'm not exactly sure. This goes up and down, and it depends. It varies from actually city to city, and it varies, of course, from state to state. When I grew up in New Jersey, and I remember when I was very young, our sales tax rate was 5%. I'm pretty certain it's higher. I don't think it's as high as California, but New Jersey, they pay a lot more. They pay a lot more homeowners tax, for example, than we do here in California. So it all kind of works out, I guess. Some states, such as Oregon, they have no sales tax. People don't pay any sales tax. So kids in Oregon don't need to learn this at all. See what they're missing? Well, anyway, in this case, so we're going to apply a sales tax rate of 8%. So what that means is that when you go to the store and you purchase something, what they do, and this is not for all items, okay, but for many items, a sales tax of 8% is added on, okay, it's added on. So in our case right here, what we're going to do, let's just go ahead and do this first one. Let's go and start right here. This is actually the same chart, just extended, that we started with, started this part of the lesson with. Remember, we had our $100 price. We discounted. It was discounted by $20. We have an amount to pay. 80% is 80% of that $100 is $80. Here is our expression. We've done all this already, okay, and this is all on your chart already. Now, our new price, therefore, over here is going to be 80. We're just going to extend this over to here. Okay, our new price is 80. Now we're going to apply a sales tax of 8%. Okay, so what I want in this square right here of this table for the rest of these is I want these to be 8% of each one of our new prices. So let's go ahead and just bring our new prices over. Okay, if you want to do this with me as I do this, these are all of our new prices. Okay, and 1160, and what's this X? All right, let's just put what is this, X minus 0.2x. Okay, all right. So let's go ahead and talk about this idea of 8% and how do we calculate it. Well, the first thing that's nice about a number such as 8% is that it's a whole number, because like I had told you beforehand, there's a lot of places where it's not so neat and clean. Okay, you might have something like 8.325%. Okay, which is not something you can accurately figure out in your head. But 8% you can, because 8% can be split up into 1% pieces. Okay, so if you know what 1% of $80 is, then you can just add 8 of those up together, for example. So I know that 1% of $80 is 80 cents. Okay. And the way I can see that, if I go $80, okay, I know that I'd have to go back 1/100th, okay, because 1% is 1/100th. So I'm going to go back here and then here, and I'm going to put my decimal point right there, because I'm talking about 1/100th, because 1% is the same as 0.01, okay. That's what that equals, okay? Because when you talk about percent, you're talking about out of 100. So all the single percents are in the hundredths place. The 10% are in the tenths place. Okay, that's why before when we had 20%, remember 20% equaled 0.2. We'll put a 0 here just so it, you don't need the 0, but we put it there just so it kind of matched 20%, 20 hundredths. That's what that is exactly. So I know that 1% of $80 is 80 cents. So how many of those 1% pieces do I have? I have 8 of those. So if I went ahead and just multiplied that times 8, I end up with $6.40. Okay, which is not a little bit of money. I mean, it's a lot of money, I think, and it's not unrealistic that, and again, like I said, around here we pay more than 8% tax. So, I mean, you're paying $80 already for something, and then you're going to pay another $6.40. Whew, man. Yeah, another way to kind of estimate when you're looking at a percentage like 8%, not too far off from 10%, okay? 10% is a great one to work with, so easy. I know that 10% or 1/10 of $80 is $8, okay? So if I know that 10% is $8, and I know my estimate or my calculation of $6.40 must at least be pretty darn close, okay? Yeah, so there we go. So that's how you find out 8% of $80 that way in 1% increments. But also another way to do it, okay, would be to just do straight out multiplication with decimals, okay, which looks of course like this. Here's our $80, and then like I had said before, it's going to be 0.08. That is 8%, okay. And again, what I tell kids is just ignore all of these decimal points right now, okay. And I go, just do all this, I just go, then I have 640, okay? I could add my decimal places up there because I have 2 of them. I say don't do it. Just say what makes sense. I mean, is it going to make sense that 8%, less than 10% of $80 is $64? Would decimal point go there? No, okay? Not going to make sense, all right? Is it going to make sense that 8% of $80 is 64 cents? No, not going to make sense. Therefore, I know that makes sense because I know 10% of $80 is about $8. 8% is probably going to be about $6.40. I like just doing it and testing it for reasonableness that way instead of adding the decimal places and going over, because that gets a little weird sometimes, okay? So yeah, we could do it that way, or we could punch it into a calculator, okay? But you need to know what to punch in. You can't do $80 times 8, okay? Or even 0.8, because that's 80%, okay? That's 80%. This, of course, is 800%, all right? You've got to know that 8% is represented this way, 0.08, because 8% is the same as 8/100ths. 8/100ths. Okay, so if we continue on here now, our sales tax on $80, 8% sales tax is $6.40. Okay, so now our overall cost, you're going to add these. You're going to add your $80, which is new price, plus your sales tax, and that's $86.40. Okay, that is going to be our total cost. Now the expression part of it all, that gets a little heady. So what you need to see though is that you need to see that when I'm actually going to skip this expression part here. So right over here we have our expression for the discount expression. This expression here, I'm going to ignore that for now, okay? I'm going to ignore the other one for now, but over here, the way we figure this out is we multiply our number, our new price, okay, we multiply that by 1.08. So it's going to be 80 times 1.08. Okay? 1.08. All right, and you can see, hopefully you can see what that does, because what that is, it's going to say, so you multiply 80 times 1, which is your 80, and then 80 times the 0.08, which is $6.40, okay, and that's going to give you your $86.40, okay. So when you're trying to calculate, if you want to actually calculate your sales tax by itself, then you're going to go ahead and multiply by, like we said over here, 0.08. Okay, that's to get the sales tax by itself. If you want to cut to the chase and just go right for it, you just multiply your price, any price, by 1.08, because this 1 takes care of the price itself. Okay, because any number, like this 80 for example, times 1 is going to give you 80. And then the 0.08 part is going to give you the tax. Okay, so here we go. We're back. We're down to our next one, which is $40. Our new price is $40. If we go ahead and then if you multiply 40 by 0.08, you're going to get $3.20. Okay, add those together, that's $43.20 becomes our overall cost. And this over here, of course, is our $40 times 1.08. Alrighty, okay. So why don't you go ahead and do the rest of these, and I'll come back and just have some answers for you. Okay, so I'm growing a little bit weary with this, but you can see my numbers that I found out, rounding as I felt I should round. 20 right here with the $22.40, adding my sales tax, which I calculated, of $1.79, ending up with $24.19. Okay, I don't care about this anymore. My $11.60, I added the 93 cents tax. That represented 8% of that, and then I got $12.53. Now over here with my X, again working with X from the beginning, an unknown, X minus 0.2X was this idea of the new price, and then or it could have been 0.8X, okay, which actually I would have preferred to have written here. So go and put that in there actually. So 0.8. No, wait a minute, 0.8x, that was actually the new price. And then if I just cut to the chase all the way to the end here, what I am doing is just multiplying that 0.8x times 1.08, okay, which represents the new price along with the sales tax like we had explained up here. So let's go over these steps just one more time before we close, talking about taking an original price, applying a discount, and then adding sales tax. A couple of steps, and these are just the first two. We'll talk about some others as well. But the first two steps, step number one would be, let's just talk about our scenario here. So here's our scenario. So we have an original price of X, and that just means that we're going to use that variable X to stand for any number, okay? We have a 20% discount that we're going to apply to that original price, and then we have an 8% sales tax. Now, that, using all of that information, we're going to get a final price that we're going to have to pay in order to get that merchandise into our bag and out the door, okay? All right, so the first step is to find the discount, okay? Find the discount. Now, in this case, the way to find the discount, and hopefully you know already, you can pause if you know and say it and shout it out loud. My expression would look something like this, okay? X times 0.20, okay? Or 0.20x, okay? This is how I can find my discount this way. So what I'm doing is I'm just going to multiply x times, and both of these, same thing, x times 0.20. That's going to find me my discount. That's my expression for that. Now, in order to find the discount after 20% deduction, okay, my expression might look like this. X, which is my original price, minus taking away 0.20x, okay? So I could take, this could be how I would find my new price. My new price is my discount price, okay? Discount price, the new price. How I find that is by taking x, which is the original price, and then subtracting away the discount, which is 0.20x. Now, these two steps, though, can be combined into one. And what you can find out is, what you'll find out is that what this equals right here, this actually equals 0.80x, or 0.8x. These are the same exact things, okay? So you could combine both of these. You know you have a 20% discount. You know you're only going to be paying 80% of that price. So you could apply, and you could just skip right to this one here, to the 0.8x or 0.80x. You could skip right to that. But for the sake of just going step by step, we'll just continue on this path. Okay, and then finishing it off here, again, to reiterate, we found the discount. That was up here. Found the discount, 0.20x. We found the discount price after the deduction. That would be x. That would be the original price. Take away that take away that discount. And now number 3 says we're going to find the sales tax. Okay, so if we find the sales tax, then we're just going to multiply this right here, the x minus 0.20x, by the tax rate, which is 8%, which is as a decimal looks like this, 0.08. Okay. After we do that, we're going to find the final total. And that final total is going to be these two expressions together, put together. And so we're going to have this one here. We have the x minus 0.20x, which is right here. That was the actual finding the discounted price. So we're going to take that discounted price and we're going to add it to the tax that we pay, sales tax, which is right here, 0.08 times the x minus 0.20. Okay, add those together. Or we could just do this. We could take 1.08, which is our price times sales tax, and just multiply that by our discounted price, which is going to be 0.80x, which is just 1 minus the 0.20x, and that's going to give us that. Okay? Yeah. Okay. Alrighty, so let's go ahead and close this thing up. Okay, this lesson was chock full of information, and very hopeful that we will see a lot of this really soon coming up in lessons 20 and beyond. But as a summary, we started off this lesson looking at expressions again, equivalent expressions. So two expressions are equivalent if they yield the same number for every substitution of numbers for the letters in each expression. Okay, so in terms of using x, if we looked at what we had just completed, if x, oops, hold on a second. If x and then 2x minus 4, is the same as, well, actually look at the 2x, oh, I don't want to do that yet. Hold on. Sorry, let me not do that. Now we're looking at square roots and such. So let me just do this. How about 2x minus 2? All right, that is going to be equivalent to, we know, 8x minus 8. Okay, it's also equivalent to something that could look like this, 8x minus 1. Okay, so these are all equivalent expressions right here. This is equivalent to this, which is equivalent to this. Okay, if all the numbers and the different expressions come out and they all equal the same, because in each one of these cases we end up with 8 x's and then 8 whole numbers. Okay, so let's see the second point here for lesson summary. So the expression that allows us to find the cost of an item after the discount has been taken and sales tax has been added is written by representing the discount price added to the discount price multiplied by the sales tax rate, and that looked just like what we had just done. And remember, that was is written by representing discount price added. So we have, remember, that was 1.08. We multiplied that by, remember, 0.08x. Okay, and what these represented here is that you have the discount price multiplied by the sales tax rate. So the sales tax rate in this case is represented by the 0.08. Okay, the original price is represented in the 1, and then the discount price is represented by the 0.8. Okay, because we have taken a couple of these steps out. But whenever you want to find the cost of an item after discount and after tax, you could write it anything like this. You could cut right to the chase instead of all those other steps. Again, I want you to be able to work with the steps, follow the steps. But if we're going to cut to the chase, cut to the very end, we could take any price. Let's say it was $50 was our original price. I can plug that in for X. I could put that right here, and I would know that that's going to be, what is that, $40. $40 I would multiply by 1.08, and I would end up with, $43.20, $43.20. Okay, so yeah, we'll work more with these discount prices and sales tax rates, but good things to know, good things to understand. Okay, so please work with your problem sets, your exit tickets. Really curious. I really want to know if you have any difficulty with any of this, because this is a lot of material. Always know that you can call or email me.